Hello and welcome to another episode of the Brookbanks podcast. I'm Ben Wakeling, the head of cost and commercial here at Brookbanks. Today I've got with me Rob Houlston, structural engineer at Brookbanks, and Shawn Galliers, director of sustainability also at Brookbanks. And today the focus of conversation is going to be around refurbishment of existing buildings, taking the fear away from it if you're a client who's a bit concerned around refurbing a building or a property that you've got, and understanding why we would want to do it in the first place, and why refurbishment has become such a hot topic over the last few years. But before we get stuck in, I will ask both Rob and Shawn just to give a little introduction to themselves. So we'll start with you, Rob. Tell us a little bit about yourself and your experience.
Okay, my name's Rob. I've been a structural engineer for about 20 years. I've done all different projects of all different shapes and flavours in that time. And that's kind of built up into getting involved into the refurbishment side of the industry, which I think is much, quite a growth area at this stage. But it kind of tests all the experience that I've built up in all those different industries. And yeah, it's quite an interesting subject.
Thank you. And Shawn, over to you.
Okay, I've been looking at sustainability in the built environment for around about 27 years now, just a little over, including some research and consulting, generally advising people how to reduce energy, reduce carbon in existing buildings and also new builds. And more recently, obviously, we're coming into the embodied carbon or the whole life carbon and indeed the circular economy. So we're looking at those as well.
Excellent, thank you. So thank you both for your time. So Shawn, over to you first. Why would we want to refurb a building instead of just knocking it down and starting again?
I think we have for a long time been looking at the operational carbon and energy within buildings and reducing that. And more recently, over the last few years, we've been looking at sort of like the embodied carbon as well to reduce that in terms of the overarching climate change and reducing carbon emissions. Retaining a building is a lot less carbon intensive in terms of the embodied than demolishing it and also then rebuilding new. Existing building has to be fit for purpose for this, for instance, and the refurbishment of that building needs to be a good quality refurbishment, and take additional carbon savings from that. But ultimately, it's about regulations about the embodied carbon within the buildings and reducing that as much as possible.
And are you finding that the reduction of carbon and sustainability in general is being focused on a lot more in recent years than perhaps maybe 10, 20 years ago? Am I right in saying that there's a real increased focus in this area now?
There is indeed, as I say, up until about 5-10 years ago maximum, everything was devoted to reducing energy, reducing operational carbon within buildings, existing buildings as well as new buildings. But over the last 5 or 10 years, we've got much more embodied carbon regulation. It started with the London Plan. The London Plan has it within it sort of like required you to do a whole life carbon assessment for a few years now, although they hadn't put actual numbers to it, but they did want you to do the test to see what you were actually producing in terms of that embodied carbon. And if you do that embodied carbon on a new build, it turns out higher than a refurbishment, which then potentially does not meet the requirements of that legislation.
So what? And I will come to you, Rob, I promise. But one more question for Shawn. Just you mentioned there about the whole life carbon assessment. Could you just take us through what that means and what it entails?
Okay, so there's several stages. It starts from the essentially the extraction of materials, the carbon, the energy and carbon associated with the extraction of materials, the actual creation of the products or the construction elements that we actually have, the transport to site, the construction itself. The carbon associated with all the energy and that associated with the construction itself, and indeed the building, and then the operation of the building. It also then goes on to sort of like the decommissioning of the building, the demolition potentially, so looking at the whole life cycle from initial digging up the materials in the first place right the way through to reusing, recycling at the end, kind of thing.
Brilliant. Okay, thank you. Rob, then over to you then. You're a structural engineer. What's your role in all this, in refurbing buildings?
Well, I think the truth is we've always kind of had to deal with the existing, because we deal with the existing site. When a building is demolished, they leave lots of things in the ground, and any developer comes along. So we're always involved. You don't just remove buildings. There's so much work involved. So it just makes sense that we want to try and reuse what we've got, whether that is foundations, ground floors, the whole superstructure. It's where we want to have our interface as a site develops. So what normally happens is everyone gets quite nervous because they're looking at something that has uncertainty built into it. And what we as structural engineers need to and like doing is working with a client to say, well, it's not your uncertainty. I can solve that uncertainty for you. I do a series of investigations. And, it's a cyclic process of questions and answers for me to then advise the client, what have you got? What can you do with it? And give them, to remove their concern. Everyone, unless you're a structural engineer, looks at a building and just sees this building, mainly facades, internals. You don't see the structure. So we come along and we say, well, hiding underneath all this is a perfectly good structure. You might need to do a bit here, and this is what you could start with. And suddenly the client's then looking at, well, actually, I don't have to just demolish something and rebuild something. And that's their gain, really.
Presumably it's quicker as well than starting from scratch, and cheaper, dare I say, or am I going down the wrong path there?
I think a lot of it is experience. If you have experience in this kind of thing, then it doesn't look so fearful. And I think that kind of goes into the role of what a structural engineer can do. If you have experienced, knowledgeable structural engineers advising a client who isn't so experienced with this kind of project, then it aids that going forwards. What you normally end up with is a client who's got involved in maybe one or two, and it just doesn't fit their normal procurement processes, their usual program developments, and they just start kind of getting a bit nervous. And what we as structural engineers need to do, and we have to do it, we have to reuse these buildings, is we have to tackle and solve this problem. And I'm pleased to say we are doing that. We it started off with just historical projects and things like that, where the planning limited you to these buildings, and now we're really challenging, the establishment. We're saying, well, okay, so you've got a steel frame here. Well, this steel frame was built according to all the old codes, where we had filing systems and so on. So all the floors are all designed to be much stronger than they need to be. So therefore, we can start putting additional stories on top. We can start looking at foundations and saying, well, can we make them stronger? Can we increase floor area? What low cost additions can we do? Can we reclad it? How can we develop what we've got? And I think,
sorry, go on.
I just think getting clients to start with that approach and up front is the key.
It's really interesting to me about those kinds of real world things that you said there about floors had to be strong enough in the olden days, in inverted commas, to hold filing cabinets and things like that. Then everything's in the cloud. So those floors are now much stronger than people perhaps think.
Right, that's right. It's I think it's also challenging architecture as well, because we have buildings that were built as office blocks, for example. And it's saying to architects who have come on leaps and bounds in the way that they're saving carbon footprints and developing how they achieve their BREEAM ratings and so on. It gives them a challenge to say, well, if you've got a building like this, of this configuration that was used like this, how can you use your skills, properly be challenged with a limitation and come up with a solution? So it's challenging those who know their art, really.
Yes, yeah. And you talk about challenging others. What are the main challenges for you as a structural engineer when you're approaching a a refurb, I should imagine the first thing that comes to mind is probably the records kept when the original building was built. I suppose they're probably in one of those filing cabinets somewhere.
Because governments and councils were so good at keeping records. I mean, they're just brilliant at it. I mean, a lot of it is, it's lovely to have records. It's absolutely lovely. But a lot of the time, we have to work with making investigations. And it's a cyclic process. We start off. So it goes down to that Donald Rumsfeld saying about, we have knowns, we have unknown knowns and the unknown unknowns. And of course, if you're turning up with a contractor and a piling rig and you're all going to start working, you can't have unknown unknowns. So a lot of the work that the structural engineers have to do is an investigative process. And the end result of that is turning to a client and saying, yes, you can do this. And of course, the client's already spent a few £1,000s at that point. And all you've done is nod your head and say yes. But it's recognizing the value of that process, because then you're going forward. And then engineers still have more work to do. We have to kind of, as the construction develops, they still have to kind of babysit the structure to make sure that things don't get done a bit differently, a bit of load added here and so on. So it's quite challenging, but then that's good. That's what we do.
And it feels to me that with it being structural engineering, if something goes wrong, it goes fairly catastrophically wrong, doesn't it? Instead of going marginally wrong.
I think what it does is structural engineering as a science, as it's developed, we have some very kind of dumb tools. Designing beams, designing columns for new builds are pretty, established, straightforward. But you really actually only know how that building, how that structure has performed when you start looking at a structure that is 50 years old, 100 years old, 150 years old. And you start saying, well, actually, if I want to start changing some load paths within that structure, how does that work? Where is it really going? And there are some absolutely fascinating projects where this has been done. And it's building up our understanding of how existing buildings perform over time. And that's going to help us develop a better science in how we can unlock more capacity in what is the UK's existing structure. This is the world we have to work with. We've got to be efficient in how we do it.
And Shawn, from your point of view then, when first looking at a refurbishment of an existing building alongside Rob, what are the key things that you're looking at and the challenges that you face?
I think with existing buildings, I think the main thing is that you, as Rob has alluded to already, is the fact that you have to fit something around that building, that structure that you've actually already got. Whereas if you have a new build, you can design it as you wish and get your elements into that without a problem. I think in terms of the sustainability and reducing the carbon out of this, though, it is very important to actually think about that right at the very beginning, to say what you take out of the building, what you put into the building, how to maximise and optimise your savings of energy and carbon going forward, including the materials that you use in terms of the embodied carbon. I know, generally speaking, in terms of structures on the larger scale things, we wouldn't talk timber, but timber's actually really good in terms of embodied carbon. But you're not necessarily going to build a skyrise out of timber, so you need to look at other materials. But there are ways of getting low carbon materials that can be added, especially when you're just looking at another floor to a building. If you add in an extra floor to a building, that hasn't necessarily got to take the structural load that the rest of the building has to take. So therefore, you can actually consider options for that in terms of the materials. But it is very, very important to think about that right from the very beginning and get the entire team involved in that as well to bring everything together.
And thinking about low carbon materials and new materials, are there any new materials on the market that are being used in refurbs that presumably have been fully tested and so on? I only ask because I'm reminded of the recent controversy. It's not really a controversy. The recent news headlines around RAAC concrete. I had to look up there to remind myself what it was for. At some point in time, that was probably a leading material in not necessarily carbon, but in construction. So what do we do at the moment to check that materials currently used and new to the market are fit for purpose?
Absolutely. I think the regulation and checking and monitoring has got significantly better over the years. Would I say it's perfect? No, it's not. I have done a stint on the other side of the building regulations, looking at the research that goes into that, and the amount that some years ago we were not actually completing in order to actually get built and pass the building regs was astonishing. It's a lot better these days. In terms of materials, in terms of the environmental qualities of materials and things like that, there are the EPDs, the Environmental Protection Performance Director. I can't even remember what that means now. EPDs, but they basically give you the entire environmental metrics of it, so you can choose a lower carbon version of the materials. In addition to that, every material that has to be tested in terms of all its qualities and that. And I'm sure Rob can tell you more about the sort of like the structural side of that.
I think what's quite interesting here is that there is the next step. And we're gathering the data to build in that next step, which is a value elevation type thing, where we're saying, well, let's build our structures so that they have reuse in them. And now we could say, well, actually, a lot of commercial developments are a shell and core structure. Well, if we know that, if you're building something in the middle of London, we're going to build higher. It is going to get redeveloped. It is going to get redone. Rather than this race to the cheapest, we need to reward clients and contractors for building in future expansion within it. And there would be no reason why they couldn't have an invested return for when that site gets redeveloped again. We all know land value goes up in value. Well, what about the actual building that's sitting on it? If very rarely, and we do come across a few of them, we have projects, mainly commercial property, that have that expansion built in. They design their first 3 stories because they think, well, actually, further down the line, the centre of, Bournemouth or Norwich or wherever, it is going to grow, and then we're going to be able to put another 4 stories on it. The additional costs of the build of putting in an extra column or a larger foundation is minimal relatively, but it's just stopping that race to the cheapest, quickest bottom.
I mean, the other driver there as well as that commercial sort of aspect is the increase in the regulation that's going around. I mean, you talk about London, for instance, the circular economy. You have to now write if you're going to do a large building, you need to write a circular economy statement, which basically looks at the flexibility of the building and also the total recycling or reuse of that building or redevelopment, so changing it, as you say, from offices to maybe residential if necessary. I've done a few of those in London. So that regulation is there, that you have to state right at the beginning of the job what you could potentially do with it in 50 years time, kind of thing. So how you are going to then reuse that building. So the regulation is coming along as well as the commercial side of it as well.
I mean, it will happen.
Yeah.
It has to happen.
Yeah.
We have to be better and more efficient at how we deliver structures with the flexibility in it. It's got to happen. So
Makes a lot of sense to, as you say, just to future-proof a building, knowing that it's going to be developed in the future. And if there was some kind of commercial incentive for that, as you mentioned, Rob, then that's just an added incentive, isn't it? But actually, you're right. The cost of additional column or a bit of a deeper foundation is fairly negligible when you consider that in the future you could add 2 or 3 or 4 more stories on top of this existing building and not have to worry about the structure underneath it. I mean, we would be remiss to not talk about cladding when we're talking about refurbing of buildings. And obviously there's plenty of developers up and down the country racing to replace cladding on their buildings, in the wake of the Grenfell tragedy in 2017. Rob, what kind of things do you need to think about then when a client is replacing the cladding on their structure? Presumably the material that the new cladding is made of needs to be fit for purpose, but also the weight of that cladding, I suppose, needs to be factored in.
I think it's a case of we can't just patch repair problems. I don't think it's here's a building, we want to reclad it, job done. I think everything that's come out of that says, no, these are very crucial components to human beings' lives, our buildings and our safety in them, and therefore we've got to do this properly. And I 100% agree. It's a root and branch approach, and I'm still it still needs to be a cultural change so that small things don't spread and become huge problems, i.e. the quality of the fire resistance of our cladding. That was started off as a small, and then suddenly the whole world was clad in it. We can't have that. We've got to be better at delivering buildings and tick all the boxes and not let cost overrun it. But it will take time. It will take time. And, you know, construction isn't straightforward. We've been building for 4 years. Things haven't gone well for years. We are better. We are good. We still need to keep pushing what we're doing. And it's just an important part of all our lives. And we should be proud of what we're doing and the developments that we're making, but it's not straightforward.
So as we get to the end of our podcast there, we're almost out of time. Rob, if a client has got an existing building that they're looking to refurb, what would be your advice to them initially?
I think the first thing clients do is that they kind of feel nervous about it. And I don't think that's the right approach. I think the right approach for a client is to do some investigation and look at successful projects that have inherited existing structures, existing buildings. You know, maybe it's a worn out office building that they just look at and think, we'll just rebuild it. But I think we need to start promoting successful projects. We need to start presenting, you know, the actual environmental gains that have happened, the carbon savings, the embedded economy. We need to flagship these buildings so that clients can see and say, yeah, that's the kind of thing I want, rather than just bulking and going straight for a demo and rebuild.
I think off the back of that as well, the local authorities, including especially the London, the GLA kind of thing, are actually producing sort of like case studies essentially of what they have been doing within their own authority. So there is material becoming available to actually look at what people have done in the past, the solutions they've come up with. So it's not as though you have to go searching hard now to actually find some things that could be similar to what you're actually looking at.
So I know we have some on our website, which kind of flagship projects that we've done. And as far as anyone would see, it looks like a brand new building, which is the clever part. Yeah. It wasn't.
Absolutely. If anyone wanted to have a look at those case studies, they're on our website, brookbanks.com. You can also get in touch with us. Thank you both for your time. A really interesting conversation. Really appreciate your insight and your input. And so it remains for me to say, Rob, Shawn, thank you very much, and see you next time.
Thanks very much.
Thanks.
Well, thank you both for your time. A really interesting conversation. Really appreciate your insight and your input. And so it remains for me to say, Rob, Shawn, thank you very much, and see you next time.
Thanks very much.
Thanks a lot.